Welcome. In this video, we are going to talk about doing Lewis dot structures for molecules. And a reminder of what a Lewis dot symbol is that's something that we use to represent the valence electrons. And the way that you draw a Lewis dot symbol is you look at how many valence electrons an atom is going to typically have using your patterns on the periodic table. And the number of valence electrons will equal the number of dots in the Lewis symbol. And then when you're drawing the Lewis symbol for an individual element, you write down the symbol of the element. Like for example, carbon, I'd write down a C, and then I'd count how many valence electrons it has. Looking at a periodic table, I'd say, okay, carbon has 4 valence electrons. And then I'm going to put one dot per valence electron. So notice how my picture has 4 dots here. And I'm going to put 1 dot on each side of the symbol. So this is the Lewis dot symbol for carbon. So the number of dots is equal to the number of valence electrons. You put 1 dot on each side of the element symbol. If you have more than 4 electrons, so like if you have 5, 6, 7, 8 electrons, you can start doubling up. So like for nitrogen, I would put 1 dot on each side. Whoops, sorry. 1 dot on each side of the N, and then the 5th electron would form a pair up here at the top. So again, it would look like this. I'd say nitrogen's got 5 electrons. So I'm going to go 1, 2, 3, 4, 5. So these are my individual Lewis symbols, and we have a separate video going over more examples with these. This video, we're going to look at what those symbols tell us and how I can use Lewis dot symbols to figure out the bonding that's happening in a molecule. So let's take a look at a couple of Lewis dot symbols here. Here's one for hydrogen, oxygen, nitrogen, and carbon. And what we'll want to look at is the paired versus the unpaired electrons. So I'm going to use a highlighter here, and let's talk about this idea of paired versus unpaired. So these examples right here are what we call paired electrons, the ones I highlighted in green. So they have like a partner, right? There's 2 electrons that are kind of stuck together on one side of the atom. And these other ones over here, so this one right here, and then these 2, and then these 3, and then these 4 over here, these are what we call unpaired electrons. So they're kind of lonely electrons hanging out by themselves. And each unpaired electron represents a spot where a bond can form. So you might remember the pattern we talked about earlier that said, remember that pattern honk 1, 2, 3, 4? That was that bonding pattern we noticed. Carbon tends to form 4 bonds, nitrogen forms 3, oxygen forms 2. If we look at these Lewis dot symbols, you will notice that the number of unpaired electrons is the same as how many bonds it will form. So like carbon has 4 unpaired electrons, and it will tend to form 4 bonds. Nitrogen has 3 unpaired electrons, it will form 3 bonds. Oxygen has 2 unpaired electrons, it will form 2 bonds. Hydrogen's got 1, so we get the idea. So each unpaired electron is a spot where a bond can form. So let's try and practice putting this together. So let's say we want to draw the Lewis dot structure for NH3. So what you would do first is you would draw the Lewis symbols for the individual atoms, nitrogen and hydrogen. So I would look at a periodic table, and I'm going to scroll back to this periodic table real quick. Sorry for flipping through this. Oh, here we go. So I'm going to be looking at a periodic table like this one to determine the number of valence electrons that an element has. So whenever I say look at your periodic table, this is what I'm talking about. And like for nitrogen, I'm going to look over here and say, okay, here's nitrogen. It is in column 5. So this right here is going to tell us how many valence electrons that element will have. So an atom of nitrogen is going to have 5 valence electrons. Hydrogen over here is in column 1, so that means hydrogen is going to have 1 valence electron. So that's where I'm going to be getting this information from, is from a periodic table like this one. Okay, sorry, I'm going to click forward again. Okay, so now we're here with NH3. So I'm going to look at nitrogen, look at where it is on the periodic table, and say, okay, nitrogen has 5 valence electrons, and then hydrogen, remember we said, has 1 valence electron. So I'm going to draw the Lewis symbol for nitrogen. So I'm going to draw an N, and I'm going to put 5 dots in it. So 1, 2, 3, 4, 5. And then I'm going to do this for hydrogen. And I've got 3 hydrogens, so I'm actually going to draw 3 of these. They each have 1 dot. And you might notice now, if we stop and look, that your nitrogen has 1, 2, 3 unpaired electrons, and then each of your 3 hydrogens also has an unpaired electron. So you can see how they would kind of fit together, kind of like a puzzle piece here. So what's going to happen here is each of these unpaired electrons on hydrogen can come over here and pair up with one of these electrons over here on the nitrogen. So when we form these bonds, it's like we are connecting these unpaired electrons to form a pair, and then that is your bond, is that pair of electrons that those 2 atoms are sharing. So here's what your final structure would look like. You've got the 2 electrons on their top that are not involved in a bond, and then you've got these ones around the different sides here. So this is our structure for NH3. And in a structure like this, now we might notice that all of the electrons are paired now, right? They're all paired up. And we have names for the different types of pairs. So the pairs that are between 2 atoms, these are bonded pairs. So these 3 pairs of electrons are all bonded pairs, whereas this one at the top is a non-bonding pair. And we often call this one a lone pair because this pair is not being shared, so it's kind of hanging out by itself. So it's a lone pair. All right, here's another example. So we're going to look at oxygen and bromine. So again, first step is you look over on the periodic table. You will know that oxygen is in column 6. That means it has 6 valence electrons. Bromine is in column 7, so it's got 7 valence. So I'm going to draw those individual symbols. So oxygen is 1, 2, 3, 4, 5, 6. Bromine is 1, 2, 3, 4, 5, 6, 7. And I've got 2 of them, 1, 2, 3, 4, 5, 6, 7. So you might notice that each bromine has 1 unpaired electron over here, and then it can pair up with that unpaired electron over there in oxygen. So again, everywhere, every spot where you see one of these unpaired electrons, I'm going to go through and I will highlight those again. So it's right here, 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 and here. Those are all spots where a bond can form. So then when I put it together, it's going to look a little bit something like this. And if you're wondering, it doesn't matter whether you decided to put the BRs on the top or the bottom or the left or the right. So for example, this structure is perfectly fine. You also could have drawn it this way. That works out well too. What you might notice though in this structure is that in the final structure for the molecule, all the electrons are paired. And notice that since we're kind of treating these atoms kind of behave like they're almost like a square with 4 sides, notice that all of each atom has 8 dots around it. So that's something else that's significant to notice here. All right, let's look at one more. I just want to point out that you can also have bonding forming between 2 of the same atom. So like Cl2, that's what chlorine gas is. That's that green gas that is not healthy for us to breathe. So this is 2 chlorine atoms bonded together. So if you look at chlorine on the periodic table, they have 7 valence electrons. And so if I draw out the individual chlorines, it would look like this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm going to draw them so their lone pairs are facing each other. So there you go. They're going to come together and form a bond right there. So, and again, think about vocabulary here. This one in the middle is called a bonded pair. And then all these ones over here on the outside, these are referred to as lone pairs of electrons. This is vocabulary that we will come back to later when we start talking about shape. This lone pair will be important. So here again is a slide kind of going over that vocabulary here, bonded pair versus lone pair. So the bonded pairs are the ones that are involved in a covalent bond. So they're being shared between two atoms. And then lone pairs are not involved in a covalent bond, but they are still important. And we'll talk more about why they're important when we get into molecular shapes. So that was a little overview of how to draw Lewis dot structures. Please reach out if you have any questions.